On this video, we are going to learn how to graph rational functions. With our given rational function, our first step would be normally to factor, but this has already been factored for us. So our next step will be to cancel what we can. So again, for our notes, first step, we need to factor. And then our second step, we would need to cancel. All right, so here we're already factored. Now let's cancel what we can. And notice our x minus 2 is canceled. So my new function that I'm going to be working with is x plus 1 times 2x minus 3, and that's over x minus 1. Now what we need to do after we factor and we've canceled, then our next step, we would need to find a hole in the graph. Anytime you factor and cancel, that means that you will have a hole or a point of discontinuity in your graph. So in order to find the coordinates of this, you will go through and set what was canceled equal to 0. So x is going to have to be 2. And then to find the y, then you go back to the reduced form. Do not use the original. And you're plugging in your 2. So that's going to give us 3 times, that's going to be 1 all over 1. So we have 3. So we have a hole in our graph, or a point of discontinuity, at the point 2, 3. Right? Once we've done this, then we're ready to do what's called our Ratey process. And so with Ratey, with big R, that means that we're trying to find our roots. And to find our roots, we will set the numerator of our function equal to 0. So we're going to take x plus 1. We set that equal to 0 and solve. So x is negative 1. And then we will also set 2x minus 3 equal to 0 and solve. And so notice we get x equals 3 halves, which is equivalent to 1.5 when we graph. So you will need to plot those points. So we had negative 1 and negative 1.5 on our graphs. So we have those two x-intercepts, and then we also had, and our hole in the graph was at 2, 3. So we're going to go over 2, up 3, and just like we would with any linear inequality, we're just going to draw an open circle there to illustrate that we have a break in our graph. So that's going to be our R. It's going to be for our roots. A is going to be talking about our vertical asymptote, and that's going to be where we set the denominator equal to 0. So our denominator is x minus 1. I set that equal to 0. So I have a vertical asymptote at x equals 1. So when you sketch x equals 1 over on your graph, do make sure you use a dashed line, because an asymptote here is really dividing up our graph, and we see that our graph cannot cross that vertical asymptote. Alright, so now let's move back over. That's going to be A. Now T is going to be a special squared term in our factored form. This T we have none. E is going to be our end behavior. And so on your sheet you will see where it talks about bottom heavy and top heavy. So when we look at this original, and if we were to pull back out what we had, the top part of our equation would be a 2x squared, and the bottom would just be an x. This is going to be what's called top heavy, as we have more value of our exponent on top than bottom. So then that means that our horizontal asymptote over on the paper that they give you, that's going to mean that our asymptote is going to not exist here. So here, top heavy, that means that here that we have no horizontal asymptote. All right, and then we're going to look at y. That's going to be your y-intercept, and that's going to be where you let x equals 0 in all the different places. So in the first parentheses, if x is 0, we're going to have 1 times -3. So I have 1 times -3, and that's going to be all over -1. So here, that looks like that's going to give us a +3 for a y-intercept. So over here, our y-intercept is going to be a +3. And so now we're ready to connect our dots. Now, the graph of this is going to look really strange, and we have to go off of some of the characteristics of what it looks like the graph is doing. Now, we do need to remember that we need to go through these points that we have marked, and then we would run parallel to our asymptotes. And so this graph on this side, and notice how it's starting to turn, and so this one would turn out to this direction here. And we know that just from the placement of here our x-intercept and our open circle. And then for our other, it looks like it's going to bend out the other direction. We do have to go through these 2 points, and we have to go through that point, and so it looks like we're going to be running out towards that direction. Now we couldn't go the other direction because of our vertical asymptote. Our next example, we will need to go ahead and factor, so let's go ahead and get that done. On top here, we do have a GCF, and so that's going to leave us with an x plus 1, and in the denominator, that is the difference of 2 squares. And notice on this time when we factored, there's none to cancel. So if I have nothing to cancel, then that's going to imply that we have no holes in the graph. So we don't have any breaks there. So let's go ahead then and go over to our Ratey process. So for R, that means we set our numerator equal to 0 and solve. So that's going to give us 3x equals 0. X plus 1 equals 0. So our 2 roots would be 0, and it would be -1. Okay, and then we would also then go to A, and A would be our bottom equal to 0. So we're going to have x plus 3 equals 0, and x minus 3 equal to 0. And so we would have the asymptotes x equals -3 and x equals +3. Now for our t in this process, we do not have any squared terms in our factored form, so t would be none. Now we're ready for E. E is going to be the end behavior, and it's going to be our horizontal asymptote. So we need to look to see if we refold out everything, then in our numerator we would have 3x squared. In the denominator we would have x squared. So this is going to be balanced. This is what your paper is saying, balanced. And then that's going to simplify. You can simplify those x squares. So that's going to tell me that I have a horizontal asymptote at y equals 3. And then finally we have y. That's going to be our y-intercept. So with our y, we do let all of the x values become 0. So we're going to have y equals 0 times 1 over -9, which is going to be 0. So now we have all of these points. Now we're ready to go ahead and plot what we can. So first of all, we don't have any holes in the graph. And then next we would have, let's see, we have 0 and -1 for asymptotes. So we need to sketch those. So our roots, sorry, not asymptotes. So we have 0 and we have -1. And then we also have x equals 3 and -3 for asymptotes. So let's go ahead and sketch those. So we've got our dashed lines here. And do put the arrows because they are lines, they're asymptotes. And then we can go ahead and plot our horizontal asymptote, which was, what was it going to be? Y equals 3. So let's go ahead and plot that. And so all of these asymptotes are acting as boundaries. It's restricting where our graph can go. And then finally we had a y-intercept at 0, but we already have that plotted. So when you're this far into the problem and you really have everything you need to graph it, what we have to consider is the fact that these x-intercepts, we have to go through those values. So here, I know my graph is going to have to go here. It's going to have to turn and come back through here. And so as far as this, how far up this goes, it's really not going to matter. Now we have to keep in mind that we cannot cross the asymptotes, so that's what's forcing this to turn back the other direction, and it's forcing us into that parabolic shape. Now with the other part, this is where knowing that we don't have a t-value comes into play. Since we don't have a t-value, then I cannot have the other piece of my graph running along the same asymptote as the middle is. So that would force this graph up here. And by the same reasoning, over on the other side, this graph would have to run this direction. And again, I know it must be there because we don't have a t-value. Not having that t-value says that I can't put graphs here and here. Okay, let's move on to our next problem. And again, by the same idea, we are going to have to start with factoring. And a quick review of our factoring. Do remember that we took that 6 and multiplied that over. So we have x squared minus x minus 12. And then we factored this for x minus 4, x plus 3. But then don't forget to come back down here and divide by 6. And we reduce that, so that's going to be x minus 2/3. And this is going to be x plus 1/2. But we're just factoring, not solving, so we have to take that denominator and move it back up. So we have 2x plus 1 in the numerator. In the denominator, we have 3x minus 2 times 2x plus 1. And so notice again, we do have something to cancel, so we automatically know we're going to have a hole in the graph. Now our original function reduces down to 1 over 3x minus 2, and that's going to be the function we work with. But we also need to go back and find the coordinates of the hole that's in the graph. So we're going to take 2x plus 1, set that equal to 0, and solve. We get x equals negative 1/2. And to find the y-coordinate associated with the x, you will substitute this back in. And please use a calculator here. If you have issues with working this out, by all means, please use a calculator. You will get negative 2/7. So the coordinates of the hole in the graph is negative 1/2, comma, negative 2/7. Now, if you go to plot that, I know that's awkward, and what you will do is end up in the third quadrant, and you will just need to put a good estimate of where negative 1/2, negative 2/7 will be. All right, now let's go through and finish our Ratey process. So we're going to go and find our roots, find r, and with r we set our numerator equal to 0. Well, 1 can't ever be equal to 0, so this one is none. So we're not going to cross the x-axis. A is going to be our denominator equal to 0. So 3x minus 2 equals 0. So x is going to be 2/3. So that tells me I have a vertical asymptote now at x equals 2/3. So let's go ahead and sketch that, and that's not quite the value of 1, so we're going to stay just to the left of 1. That should be sufficient. And do make sure you put your arrows on the end. And now the next part of Ratey, we would look for t, and it doesn't look like we have any squared terms in our factored form, so we have none. E in behavior, this one's going to be bottom heavy because we don't have any powers of x on top, and we have x to the first and bottom, so this is bottom heavy, and anytime this is bottom heavy, we have the horizontal asymptote of y equals 0. So here we have this asymptote, and I need to change color so it'll show up. So we have our horizontal asymptote, and that does line up with the whole no x-intercepts. And let's see, RATE, now we're ready for y. Y will be your y-intercept. So we're going to look at our function in the reduced form and substitute in a 0 for x. So that's going to be 0 minus 2, which is going to generate negative 1/2 for us. So I have an x-intercept of negative 1/2. So that means I'm going to have a point here. So now we have to figure out, well, what in the world does this graph look like? Well, we for sure have to go through these 2 points, and we can't cross over our horizontal asymptote, so I know it's going to look like this. Go through our y-intercept and continue that direction. Since we don't have an r or a t value, no t value, so that means that my graph cannot run parallel. So I can't put the other side of my graph here. So by default, I have figured out that the graph must go up here. So that's going to be our rational function. Okay, with number 4, again, same process. We would need to factor and cancel first. This has already been factored for us, and so we can go ahead and cancel, and that's going to leave us with the function 3 over x minus 3. But now we also need to find the hole in the graph, so we need to set what we canceled equal to 0. So I'm going to have x minus 2 equal to 0. So that means x is going to be equal to 2. And to find the y value to go with it, we're going to resub in back up here. So that means y equals 3 over 2 minus 3. So we get negative 3. So the coordinates to the hole in the graph is going to be 2, negative 3. All right, now that we have that, we're ready to start our Ratey process. So r is going to be our roots. We set the numerator equal to 0, and again, that can't happen, so we do not cross the x-axis. A is going to be setting the denominator equal to 0, and that's going to generate our vertical asymptote at x equals 3. So over here at x equals 3, we should have an asymptote. T, once again, there will be none for these problems here. And so that means we don't have any special square terms in our factored form. E is going to be our end behavior. And so if we look at our graph, we have 3 over x minus 3. So we see that we are bottom heavy. So that means y equals 0. And then we have our y-intercept. So x has to be 0. So we're going to have 3 over negative 3. And that's going to generate a negative 1. So that's going to give us a point over here too. All right, so let's go ahead and go through and label all of the values that we found. We found a hole in the graph at the point 2, negative 3. So we need to go over 2, down 3. And we have a point of that discontinuity in the graph. We don't have any x-intercepts. We do have a vertical asymptote at x equals 3, so we do need to note that. So we're going to have our asymptote here. Okay. And then let's see, RAT, we found our asymptote. Then our end behavior, which is our horizontal asymptote, is going to be y equals 0. And again, that's lining up with the fact that we did not have any x-intercepts. So again, we have our asymptote that runs this way. And then, let's see, we have our y-intercept at -1. So here, y is at -1. And so going ahead and graphing this, you know you have to go through those points and run parallel to the asymptote. So there's one part, and again, you had no t-value, so you can't put any graph down there. So that implies that the remaining part of this graph must go up here.